Hi, I'm Sok from Learn, Do and Grow. Currently, are you facing any difficulty teaching your child PSLE's math? Or are your child having difficulty solving any challenging word problems? Are you confused with the current problem solving techniques whereby students are required to identify question type and use the given approach to solve it? Do you want to know how I solve 80% of challenging word problems with just one star strategy and technique? If you want to know how star strategy and techniques help you solve all the question types in the topics such as whole number, fraction, percentage, ratio, and decimal, this video is for you. By the way, I'm the author of Mastering Model Method, a 3-step process to solve challenging word problems with star strategy and technique. Also, I'm a math coach, a former ASEAN scholar, and a certified trainer. Before I show you how to simplify a complex model into a basic part-whole model or a comparison model, which a primary 3 student can solve it, I would like to show you a comparison between the current problem-solving technique and the STAR technique. Let us look at the current way of solving problem sum. Currently, if you have a question over here, then the student was taught to identify the question type. Is it a repeated identity concept? Or is it a remainder concept? Or is it a before and after concept? And within each concept, there are different scenarios. Like you see over here, there's so many over here, there's so many over here, and there are others which I can't be possibly putting everything here. Once they identify the scenario given, then they select the approach to solve it. And after that, they do the calculation to find the answer. But the problem is, most students unable to identify over here. They get confused. So a lot of question mark. They get confused. Once they get confused, the question is stuck. And they have no way to solve the problem sum. This is a reason why most of the students are unable to solve any challenging word problems. But I have a way to overcome this problem by using the STAR ways. So how does it work? Let's look at this. We have a question over here. So instead of identify what are the question types and what are the approach to use, we just answer one simple question over here. Let's look at it. What is the relationship between the bars models? So later on, I will show you how to answer this question using the STAR strategy and technique. And from there, a complex model can be simplified into just a basic part-whole model. And even a primary 3 student can solve it. From there, we can find the answer. Here is the secret to solve challenging word problems. So what are the 3-step process? We have over here DAD. I call it that process. So D, what is D stand for? Drawing model. Why do we want to draw the model? Because we want to gather all the information from the question and put it into a few models. And after that, A is adjusting the model. Normally, the question they give you is complex, so the model is not so straightforward, and it is very difficult for comparison, or it is unable to compare. So in order to do some comparison and have a meaningful comparison, we do adjusting the model. And why do we want to do that? Because we want to find a hidden information. So the moment we adjust the model, we standardize the unit, we can find any hidden information on that model itself. Once it is simplified, then we move to the next step, which is the deriving one unit quantity, meaning finding one unit quantity. And later on you will see, the moment we can find one unit quantity, we can use it to find any answer that the question is asking. In order to help students to remember how to use STAR to solve any challenging word problems, we can ask the student these three questions. 1. Why do I need to find one unit quantity? And what do I need to do? And how do I do it? So from these three questions, you can solve any questions. So from these three questions, solving any challenging words problem becomes so logical. Am I right? Let's go through this process again. Why do I need to find one unit quantity? Like I explained earlier on, the moment we find one unit quantity, we can use it to find any answer that the question is asking. And the next step that is so logical about this is that, so what do I do? From there, after you know what you need to do, the next question you ask, then how do I do it? Let's look at this diagram. Okay, a lot of students or even parents, they do not really pay attention on these two models, which is so basic. So they only focus on just the challenging word problem, and they practice and practice and practice. End up they only practice what they know, but what they don't know, they will not be able to solve it. So this type of practicing is not advisable. What we want to study is to study smart. What do I mean by study smart? Study smart means that we can foresee what type of question that examiner is going to ask. And from there, we prepare. So let's look at these two basic models over here. So any models, after it is simplified, it will look like either this or this. Okay, so I call this as a smaller quantity, larger quantity, and everything here is the total. So if we look at it, if the larger quantity take out the smaller quantity, we can find the difference. This is the basic. You need to know this. We use a lot later on. And over here, it's the same thing. We have smaller quantity, we have larger quantity, we have the total. We also have the difference over here. But the main focus in this model is that I focus on the unit. So the smaller quantity, the quantity per unit is equal to this quantity per unit. That's why they have the same color. And this is important too. So the moment we can find one unit over here, regardless of the question is asking, we can find it. For example, the moment I know one unit, if the question asks me to find, okay, what is the total? Okay, very simple. What is the total? 1, 2, 3, 4, 5, 6, 7. Just take one unit times 7. What if they ask you to find the smaller quantity? Smaller quantity have how many units? 1, 2. We can find that. What if the question asks you to find the larger quantity? We do the same. So how many types they can ask in this model? They either ask you to look for the total, the smaller quantity, the larger quantity, or the difference. So you see, any complex model can be broken down into this type. Okay, but the challenge is this. The question is not so straightforward, and they gave you this type of model. So what do I need to do? You need to do is to find the relationship between models. It's simple as that. You don't need to identify any question type. You don't need to know which scenario it is. You just need to know the relationship between the bar models. What I mean is, in scenario 1, this is the bar models. Okay? In scenario 2, this is the bar models. How do they relate to each other? The moment you can find that relationship, that is the time that you can break the complex model into a simple models, which later on I'm going to show you. So what are the bar models that examiner can set? Another type is to compare between two things. So for example, model A is over here, so the quantity per unit over here is not the same as a quantity per unit over here. If you look A over here, maybe I can draw here, over here, B is from here to here, and B is longer. So in this case, you can't do a simple comparison too, so you need to standardize the unit. Another one is that this is a bit easier because the unit over here and the unit over here is equal to each other. But the problem is this: I have extra over here and I have extra over here, which make it difficult for comparison. But don't worry, STAR strategy will be able to help you simplify that model. And the next one, this one normally is a bit difficult for the student to solve it because it's not so straightforward. This one, we need to answer the same question over here. What is the relationship between the bar models? If you notice, A, the unit, and A, the unit over here is the same. B and B is the same. But the question do not tell you how A and B is related to each other. So it is very difficult to make it standardized and to find a answer that we want to look for, which is one quantity per unit. This is what I mean by asking ourselves, what do I need to do? So you need to do, by now you should know, is to find the relationship between bar models. Relationship between bar models. The relationship between bar models. And the relationship between the bar models. And these are the 4 types of questions that they can set regardless of any scenario given. So how do I do that? For this type, we use S, the standardizing unit. Remember what it starts as? T-A-R. So S is over here. So in this case, what we can observe is this: the relationship between bar model is over here, and over here. So if you notice, their quantity is the same. If the quantity is the same, can I make both bar model to have the same number of units? Of course I can. So in that case, I use standardizing unit, and from there I can change it to over here, and this one I can change it to over here. And how many units are there? 1, 2, 3, 4, 5, 6. 6 units. And the moment we can find that the relationship between the model A in the first scenario and the second scenario, we can use it to link back to model B. So let's look at it, the bar model B. If originally over here 1 unit is 3 subunit, in that case over here also 3 subunit, and 3 subunit. And for this bar model, original unit is 2 unit, can be divided into 2 subunit. So over here is all 2, 2, 2, 2, 2. And look at it, the moment it is all subdivided, the quantity per unit is the same. It is just a basic comparison model, which is something like this one, right? So we have the smaller quantity, we have the larger quantity, and we can find the total quantity over here, or they give it to you, or if they don't, they ask for it, then you just look for it. So this is just one type of STAR that can help you solve the question. What about the other type, which is this type? If you look at the hint over here, you see that part B, 1 unit of B is equal to 1 unit of A plus 1 extra thing, which I highlighted in yellow over here. So in that case, the whole model can be redrawn as this: 1 unit, 1 unit, 1 unit. But in 2 unit, right, how many extra thing I have is 1, 2 extra thing. And from there, it become a basic comparison model. You have the total, you have the number of unit, you have the extra, and you just take out the extra, then you will get that 5 unit equal to the total. And from there, you can solve the question. The third type, this one, if you notice, you have one extra here and lack of something to make it into 2 units. In that case, I take the total to add this over here, I add it up, then I become 2 units. While for B over here, I have extra, right? So I take it out. If the moment I take it out, I minus it from the total. Then you look, become a normal part whole model or comparison model. Again, you have the number of unit, you might have the quantity, then you have the total quantity. From there, you have 4 things, right? Smaller, difference, larger, total. Definitely, they will give you enough information to find the unknown. The last one. The last one is this. It is a bit difficult to compare between A and B. So the last strategy is we eliminate one. In this case, look at the scenario 1. We have 1 green, 2 green, 1 orange. Scenario 2, we have 3 green and 2 orange. So how do I eliminate one of it? In that case, I can make the orange over here to have the same number as the second scenario. So I take scenario 1, I times 2. So what happened is this. The moment I scenario 1 times 2, this is how it look like. I have 2 over here, and over here I times 2, I have 4. And the total I need to times 2 because everything increased by 2 times. And from over here, I compare scenario 1 and scenario 2. Then look at it again. It is just another comparison model. I have a larger quantity. I have a smaller quantity. You got it? And look at it. Orange, 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 orange over here is the same quantity. I can just eliminate it. So I only focus on this part. So I have 1 unit, 2 unit, 3 unit, 4 unit, and over here I have 1 unit, 2 unit, 3 unit, and each quantity per unit is the same. And from here, I'm very sure there are enough information given so that you can find one quantity per unit. From there, the question is solved. So to help the student to learn the smart way, I'm writing this book, Mastering Model Method, the 3-step process to solve challenging word problems using STAR strategy and technique. This book will help you as a parent to change the way you teach your child. Rather than ask them to memorize it, you teach them the logical step to solve any challenging word problem. And for the student to self-learn, the book will teach them step by step of how to think to simplify any challenging word problems into a basic one. And from there, it is very easy to solve any challenging word problems. If you want to learn more with more application, with more scenario, and how do I use STAR strategy to solve 80% of the challenging word problems with just one strategy, you can sign up for our STAR webinar. It is a 1.5 hours long, and I will teach you and I will show you the application with a given real example and see how you can use it and apply it to solve any challenging word problems. And you have to act fast. Space is limited. I will see you in the webinar. Thank you for watching.